Hey everyone, this is Martin. This is part 16 of the C++ OpenGL FPS devlog, and we have physics debug lines rendering. Finally, last I did this over the on and off over like the past week or so. Hopefully you can see this smoothly. I've still using started using OBS Studio and reduced the screen resolution down, the render resolution down heavily. But yeah, there you go. So these dark green lines that you see in there are the debug lines of the physics colliders that bullet, using bullet. So I'll walk through the code in a moment, but these lines are provided by the bullet framework or bullet library, and then you can, based on the vertex data that you get, render the lines however you want. So this is level 2. Let's just pop into level 3, and the cool thing is, I think I mentioned it in the last video as well, but my suspicion was that the reason why I was getting some wacky physics of being able to sometimes go through walls and so on was because the capsule collider is indeed on the floor, and it's sideways, so it's basically lay on its side. So you can probably see that there a little bit. There's one end and there's the other end, and you can see the walls here. I was testing out, okay, if I increase the wall's height and leave a gap underneath, I can still move through them, even though visually I should be bumping into them, like this wall here. So, and it made sense. Okay, well, why can I get close to the wall from this angle here? Because there you go, the collider's right in front of it. But from this angle over here, I'm much further away from the wall, and again, it's because the head of the collider is bumping into it. So yeah, my theory was correct, but I wanted to do this anyway, just to be sure, and also to debug problems like this in the future. So now let's walk through the code. So hopefully this is useful to some other people as well, because it's a popular library, bullet physics. It's used in a lot of games. I think it's also a Python package as well, but I'm using the C++ implementation here, or C++ library. So what I'll do is I'll walk the way through how I got the debug lines to render, and then hopefully that's useful for some other people out there as well. So this is half kind of like devlog, half helping people out if it works. So the first thing that I needed to do is I needed to create a class which implements the BTI debug draw interface, and I've called this class bullet debug draw. You can see it here. This is within my engine source code. What you have to do, and as it mentions in the bullet physics stuff, I'll sync this up as well, just so where you can see it. This lives in the bullet source linear math, and it's down there, bullet I debug draw. And there wasn't a ton of notes on this really. Like comments were a little bit useful, but not fully useful. But it says here, yeah, sorry, I can't talk, it's late guys. The BTI debug draw interface allows hooking up to debug renderer to visually debug simulations. Yep, create a debug draw object, and again, that's what I did, and it's implementing this debug draw interface, and assign it to BT collision world or BT dynamics world using set debug draw and call debug draw world. I'll show you what that means in a minute. A class that implements the BTI debug draw interface will need to provide non-empty implementations of the draw line and get debug methods at minimum. For color arguments, XYZ components refer to red, green, and blue. I've not done color. I need to loop around to that next, and there's a few other things I need to fix up. But yeah, so let me just again step through what I did. So all of the functions that I needed to implement, well, all the ones that I did implement are here. So basically, as you can see, override. It mentioned that I think we just needed to have the get and set debug mode maybe, and then also the draw line. But I did a few of these because these ones had to be overridden because these were pure virtual functions inside of the BTL debug draw. So even though it said at a minimum you need the set debug draw and debug draw world, so there's set debug, sorry, again it's late guys, set debug draw, I'm looking at the wrong line, sorry, implement instances of draw line and get debug mode, sorry. So draw line and get debug mode, I needed the other ones as well because they are virtual functions. Sorry, they are a pure virtual function, so they've got that equals 0 in the end, and therefore they had to have been implemented in any kind of class that implements this interface. So there you go, equals 0 equals 0. So anyway, those are all of the ones that I needed to write here. I've also added those in to my debug.draw.cpp, wherever that is. Oh, I don't know why it went up there, but okay, whatever. Let's just get it down here. So here's all the implementation. Again, I'll walk through this in just a moment, but yeah, there's the CPP file anyway. All it does is it just defines these each of these functions that I've declared here, which have been overridden from the bullet physics library. So first thing is, what I had to do was within my physics manager, this is separate to bullet. This is my class that handles physics, this physics manager. I created an instance of this bullet debug draw here, just as a private variable. Then when I initialized it, I pass in to the mWorld object, which is this discrete dynamics world type. I've passed in what is the debug draw. I'm setting the debug draw and then passing it the address of the debug draw object, which again is just the address of this thing here. Then what I needed to do was every single frame, where in my case when I'm calling update, I need to do draw debug world. Okay, and that's all I needed to do from the physics manager, from something that's outside of the debug draw class that I implemented. So what happens is, and hopefully this is where I had to do a little bit of figuring out and sorting things to understand how to get it to work. But ignoring my implementations right now, these are kind of my things. Get debug draw mode. This one has to be non-zero in order for it to draw lines. So what I've done is I've created this variable here, like mDebug draw mode. This get debug draw mode is called from the bullet physics library. I don't know if it's from this class exactly, but it's called, and it needs to know what do you want to draw. So in my case, what I've done is I've just set it to debug wireframe. All of the enums for this live inside this debug draw, this bullet I debug draw there. So I just want to draw the wireframe, but there's a bunch of different options. I've not tried them, but yeah. Next thing is set debug mode. I don't call that. I've just implemented it here, but it's not actually being changed or used. What I probably will do is I'll be able to turn this on and off, so I can set debug mode to the no debug. In that list of enums here. There you go, and then it'll stop pushing the lines to be drawn to my class here, and speeds things up. So the draw line function, this gets called on all of the lines that you are rendering, or all of the individual lines multiple times a frame. So let's say if I have a quad, and what bullet physics will do, will give the outline or the debug line as 1 line, 2 lines, 3 lines, 4 lines to fill that quad. So this draw line will get called 4 times per frame, containing the from and the 2 vectors of the XYZ coordinates. Okay, so that's what I was having a little bit of trouble with at the beginning and figuring out, okay, how do I know where it ends and so forth, or how many froms and twos are there? If you've got a very complicated level, it's going to be hundreds, potentially thousands. Okay, so anyway, I won't talk about this one just yet because that's my implementation. But the draw line, just so you know, that function that you've implemented from the BT, from this one, the BT debug draw interface, gets called multiple times per frame. It calls once for every single line that needs to be drawn within the scene. The flush lines, that gets called whenever it is now finished sending all the lines, processing all the lines. So let's say, again, keeping it a very simple example, you've just got one quad in your scene with a bullet physics collider, that's going to send call this function 4 times with the from and to for each of those lines. Once it's done those 4, you're going to get this flush lines call. So that is where you know that the end of the all of the data for the lines has been sent to you. You know you can then do what you need to do. And I'll explain this more in a minute what I've done here. Clear lines is called when it's about to send the data again. So this is kind of like, I should maybe reorder these a little bit, but anyway, in fact I might just do that right now if I pop this up here. So clear lines is called first. That's basically, hey, we're about to send you a bunch of line data. Then draw line, again it says draw line, but you can implement it however you want. This is just the way that what they've called it. And then after that as well, if I just go, in fact I'm going to reorder this one a little bit, it's called flush lines, which is like basically the end of the line data. Okay, so that's how it knows, that's how you know to process the data. So that is the how can I put it, that's the overall explanation of it. What I'll do as well is I'll just go to the top of my H file here, my debug draw H file, and I've just written out basically the order of things of what I've just said there. So if you want to pause the video, and hopefully you can kind of see that okay, that explains roughly what's happening. And I'm going to forget this in a few days, so I always write down like big books of comments. So the way that I'm handling rendering, or I guess to be clear, bullet physics will not draw it for you. It will provide you the data of all of the from and to and the lines, the draw lines in this case. I don't know about the circles and all the other bits and bobs that it does, but pretty sure the bullet physics will not do any rendering for you. That is up to you how you handle rendering. So if it sends you a bunch of lines, you render those lines however you do that, whether that's through like DirectX or OpenGL like myself here, whatever. So this is where it's my implementation. So what I've done is when this bullet debug draw is first created, I'm just going to listen to the on scene fully loaded. That's basically the event to say, hey, scene's fully loaded, now I can spawn a debug mesh. And by the way, the video that I did maybe 2 or 3 back on like a global event system, this makes it so easy to just listen to this. Like I didn't have to call this from like let's say the scene.cpp file and then look for the physics manager to call this. No, I just called through the global event bus the type of event that I wanted to listen to, and then what I want to do when that event gets fired. In this case, spawn the debug mesh. So all I'm doing, again, this is very like specific to this. I guess we could call it an engine, C++ engine. It's more like a framework, I suppose. It's not. When I think of engine, I'm thinking of Unity and Unreal, but this isn't a general purpose engine. This is just a framework for my, maze game that I'm building. Anyway, spawn a debug mesh. Creating the debug game object, that's basically what this does within the scene. Getting a material. At the moment I've just made a debug material, but I need to make an unlit color material, which I'll come back to, because right now it's very dark, and debug lines just meant to be unlit, just straight red or green or blue or whatever. Setting the position to the middle of the world, because the lines that you get here when draw line is called, these are like world positions. So that's why, let's say if I've got the quad is at position, one of the lines starts at like position x15. If I was to put like an extra 5 here, then it would add 5 to that 15, and it wouldn't line up with the visual meshes. So that's why I've put this at the 0 position in the world here. Then this is my implementation of create lines. If I go into just to kind of show you how that works, all I've done is I've adapted the create plane function here, which defines like a bunch of vertices. I'll show you here, but all I'm doing is taking in the vertices as opposed to like predefining vertices. So a plane is obviously like, predefined, it's creating a plane. We don't have to pass in any vertices because it's just a plane. Whereas create lines 3D, you can pass in arbitrary number of vertices. You know, like you can pass in hundreds. You can, you know, draw an entire house if you wanted with these create lines 3D, which is pretty cool. I think, you know, like the way that OpenGL works. And I guess any graphics API, you can just pass in like a bunch of vertices, a bunch of vertex data, and it'll just go through those one by one, rendering each of them in the graphics pipeline based on like the, I think it's the vertex attribute pointer in OpenGL. So basically, how is it laid out? How's this data laid out? Which is what I've got here. So I'm saying that it is, it's a three, how can I put it? It's got 3 points of data. So in this case, X, Y, Z. And this is what this is defined as, like, how is this to be drawn? How is the GPU going to interpret this bunch of floats that I'm sending through? You know, is it X, Y, Z? Is it RGB? Is it X, Y, Z and then UV after that? And then after that, has it got tangents or whatever? So the GPU doesn't know how to interpret that data. So this is what this is here. It's telling it, hey, it's just X, Y, Z in this case. I'm going to have to add another one here for color as well. I think I've got one up here as an example. That's a UV. Normal there. UV coordinates. Yeah, that's the other opposite of the normal as well. But anyway, I'll have to add another like vertex layout as well. This is kind of, just as I'm talking about this, is kind of interesting to dip back in. This part of the code is based off of the engine tutorial that I followed on Udemy. If you're interested and want to check it out, I'll put a link in the description. Just full disclosure, that is an affiliate link, but it's a great course. I mean, I basically gave me a really good foundation on which is about to build this FPS maze game. So anyway, we create the 3D lines, passing all the vertices. Those are then passed to the GPU. If I go back to the, let's just go back here. I'm saving a reference to that debug mesh, not the game object, because I don't need a reference to the game object. I just need the mesh in order to update the vertex data. And then all I'm doing is adding the mesh component with the material and the mesh. And true here is I need to improve this, but it's basically saying, hey, this is a debug mesh, render it after everything else. And that's happening within the render queue here, where I've created a new render pass. I go down to 3D debug pass. Yeah, that is correct. So just a new render command 3D debug, which comes after everything else. So after the UI pass, after the 2D pass, and then after the 3D pass. So anyway, that's kind of besides the point of this video. I shouldn't really complicate it that much and go too much on a tangent. Anyway, so I create my debug mesh so that I can pump data into it. Okay. Next thing is, once clear lines is called, my vertices here, which is all I've done is create an empty vector of floats, line vertices, and it's just clearing it whenever it's about to send us new data, whenever the bullet physics library is about to send us new line data. So cool, that's how we know we need to like clear it out. Then all of the from and to, I'm just pushing them into the back of that vector of vertices. So starting with the from point XYZ and then the to point XYZ, all just side by side. You know, this is just like, you know, first time around this is going to be element 0, then 1, then 2, then 3, 4, 5, and it's just going to keep on pushing it as many lines as many times as it needs to do. And then at the end of it, boom, flush lines, we know we're finished. We've sent you all the data that we need to send you. Now you can render it however you want to render it. And in this case, in this engine, I'm doing an update dynamic call, which is basically pushing the new vertices to the vertex buffer object that already exists on the GPU. Again, I'm a little bit, this code here that you're looking at right now is part of the engine that I followed along with on Udemy. I'm still, when I dive into this, kind of learning a little bit as I'm going, but we're binding the vertex buffer here. We're then sending the vertex data to that buffer. Now, at first I thought, wait a minute, can it take a different size, or does it need to be a set size? Like, what if I set up the vertex buffer initially as 10, but now I've got 100? Is that going to be a problem? Doesn't seem to be a problem, because it's almost like I'm defining the size again here, which I am in fact. you know, first time around it could be 4. Like you saw the level when I played it at the beginning was a much simpler level with only 10 or whatever it was. But then we're sending more. Now, actually, I'm going to go back on myself a little bit here. Sorry. I've kind of figured something out in my brain. Whenever I load a level, whenever a new level loads within this game, this whole mesh class here gets recreated. Okay, this whole thing gets recreated. It knows what I'm trying to figure out here, guys. Sorry, I've got on a little bit of a rabbit hole in my own head. Is maybe one of you out there know the answer to this, but if I create a vertex buffer, do I need to know the size from the beginning? Based on what I've just explained there, I don't think I do. I think because this vertex buffer gets called for each level. The first level, there's only a few lines, so let's say it's 10 lines, so the vertices size is going to be 10 times the size of a float. But then the third level, which is always more complicated, that's got, you know, hundreds by the looks of it, hundreds of lines, but this still doesn't break. So does it need, can it resize? So if I, you know, on the second frame, if I pass in like vertices bigger, will this allow it to draw or will it break? I don't know. I don't. Anyway, sorry, I've gone down a bit of a tangent in my own head there. But anyway, I'm pushing the vertex data to the vertex buffer here, updating dynamic and using GL dynamic draw. That basically says like, hey, the data within this vertex buffer is going to change, and it doesn't change. Because it does change. Sorry, it does change because I, the player walking around, that capsule that you're seeing is going to be different each time. So it's going to be, you know, based on the position of the player. So this, in fact, it does allow you to update those vertex buffers dynamically, which makes sense. You know, you get games are always going to have dynamic vertex data, but this flag here, from what I understand, is saying, hey, GPU, this data, this vertex buffer is likely to change. So I'm going to tell you so that you can optimize it slightly. I think that's the way it works, as opposed to GL static draw, which means the vertex buffer, the data in this vertex buffer isn't going to change very often. That's my maybe very rudimentary understanding. Sorry guys, I got on for a little bit of a tangent there, but anyway, when the scene loads, we create a debug mesh that we're going to be sending the line data to. Before the line data gets sent to us, this clear lines gets called, so we need to clear out the vector. Then we're going to be sent every single line, multiple lines within the scene, depending on how complex it is. And then flush lines, when we know we're finished and we can update that, then the rest of the rendering system takes over at that point. All I've done is after this debug mesh, this is kind of a little bit not relevant to the bullet physics stuff now, but what we've got is in update. If I go to update dynamic, is it update dynamic? Where is it now? I think there's a draw debug. I don't know, sorry, where was it now? I'm just trying to figure out where the... Oh, it was the mesh component. Sorry, I don't think it was the mesh component allows for creating a render command, which we send to the render queue, if I remember right. I have it again. There you go. Update. There you go. So, okay. So the mesh component, the way that I think of it, or the way that I've sort of named these things, is like in Unity, a component is something that lives on a game object. In this case, it's the mesh component, and the mesh component contains a reference to the mesh. Here we're saying, hey, this is a debug mesh, so create a render command 3D debug. And then at the end of the frame, after we've done all the physics update and we've got the user input, what we're then doing is we're calling the renderqueue.cpp, which I showed you before. So after we've done the UI pass and the 2D pass, etc., then all we're doing is looping over all of those render commands, setting up the shader program to use the uniforms, the projection. Again, this isn't to do with bullet, this is just how rendering works within this particular engine. the projection matrix so that we know how to convert the model space or view space into world space. I forgot what conversion it is. The model view projection matrix, and then finally we're doing draw debug mesh there. So the draw debug is actually within the mesh component, I believe. Yes, it is. And all I'm doing is draw lines. I've not done draw elements, which allows you to take in an element buffer. I'm not too concerned about that right now, to be honest, because it's debug. It doesn't have to be super efficient. You know, if it slows it down a little bit, that's fine. If I was drawing lines then like for the game, then yeah, I'd try and be a bit more efficient. I might loop back to that, but you can see here, yeah, draw elements and then index count. I've got to figure this out. I've got to kind of reread this and understand like where all this data is coming from. Anyway, I just wanted to talk a little bit how I'm handling rendering, and so hopefully it's useful to other people as well. But that is how it works. I will leave a couple of references that I used as well, namely these ones. Bit on Stack Overflow, a couple of references, the bullet physics one, and then somebody else's engine as well. They kind of pointed me in the right direction, but there were a couple of blanks that I need to fill in myself as well. So I enjoyed implementing this and just figuring out and understanding. Because that flush lines thing, I had to figure that out for myself. I had to figure out this clear lines, what was happening there. I had to write in a bunch of debug stuff to understand what the heck was happening with draw line and how that works, and you know, oh, how do I know it's the end of the data? Well, that's what flush lines is, and why it wasn't working, because I wasn't, you know, overriding all of the necessary functions as well. I don't know, where's my H file gone? Did I close it? Oh, it's gone up there for some reason. That's odd. But yeah, I needed to override like all of these ones as well to get it to work, and so on. Also made the physics manager a friend class so that I can only instantiate it from the physics manager. It doesn't need to be anywhere else. Anyway, it's late. I hope that was useful for anybody who's coming across like bullet physics, debugging, line drawing in C++ as well. And yeah, any questions, guys, just pop me a ping in the comments. I'll see you later.